Yeah. All right. Number 2. F of x equals 6/5 to the x. First thing is it growth or decay? Why? The b is bigger than 1. That's exactly right. So we know it's growth, and we need to graph it. So tell me what you know. A is 1, B is 6/5. There you go. All right, where's my asymptote? 0, because your k on the end is also your asymptote. Give me a point that's on the graph. 0, 1. How can I find another point? Pick a point, Pat. I'm going to stay close to this, so maybe I pick 1. I stay close to the x on the first point, okay? So maybe I pick 1, and if I plug in 1, then I get 6/5 to the first, which is 1.2. So that means it goes up a little bit right here, and I can kind of tell what's happening. Terrible rendition, but it's okay. Oh, okay. Did somebody say 6? 6 and 7. All right, number 6. F of x equals 3 to the x minus 2 minus 7. Growth or decay? It is growth because b is bigger than 1. Where's my asymptote? -7. No, it'll never touch the asymptote. Am I above the asymptote or below the asymptote for this one? Above. How do you know? It's positive. Look at you, BJ. I'm impressed. All right, give me a starting point or a point on the graph, a good point I could use. 2, -6. This is h, a plus k, right? 2, -6. Now pick a point. I would probably do 3 here if it was me. I tend to go 1 to the right, and the reason for that is when you do that, it makes your exponent 1. It just makes it a little easier. There's no right or wrong here. You can pick whatever point you want. Yeah. Yes, it's just sometimes it's not going to be, well, and sometimes it won't be feasible, like if you get 35 for your y-intercept. But yeah. All right, I got 3, -4. I'm going to go with that. That's fine. Yeah. Domain. It is. It is. In fact, all of these are going to be -infinity to infinity on the domain. For every exponential like this, yes. But the range is what's restricted. What's the range here? What's the lowest the graph ever goes? Negative, close. 7, just because it's not actually 7, that's why I do the parenthesis, it becomes really, really close. -7 up to infinity. If it's above the asymptote, yes. If it's below the asymptote, it'll be -infinity to the asymptote. Well, you always go down to the asymptote itself. So this asymptote is y equals -7, so that's why I went to -7. It is a times b to the x minus h plus k. Change h and keep k the same. What else? What else? What else? What else? In behavior, do y'all need the rest of the analysis, or you just need the graph? Yeah. In behavior, as x approaches infinity, what does the graph do? There you go. How about as x approaches negative infinity? Yes. You need a sheet too? On the in behavior, yes. If I put in a 0 for x, I get 3 to the 0 minus 2, which is 3 to the negative 2 minus 7, which just flips it around, so it's 1 over 9 minus 7, and you can use your calculator to kind of figure that out and get a decimal. What's 1/9 minus 7? Yeah. So y-intercept is about negative 6.89, 6.9. No, so the negative 3 to the negative 2 is the same thing as 1 over 3 to the second, which is 1 over 9. When it's negative, but it flips and becomes positive. Say that again. The b, which is the base, the one that has the exponent hooked to it, if it's bigger than 1, it's growth. If it's less than 1, it's decay. Yeah. Yeah. All right, does that answer your questions about that one? Yeah. I'll do 9 first since it comes first. It is hot in here. I think it is now. It doesn't yet. I got below 70. You know how to override it? No, because I don't want to break it. Right, because I want it to work. All right, tell me what you know. Is it growth or decay? Well, it's your B that determines, not your A. So it's growth because it's bigger than that. Right? All right. Where is my asymptote? Is it above or below the asymptote? Your K. Your K is your asymptote. Positive A is above, negative A is below. Give me a point, a good point on the graph. Yeah. Negative 1, 1, 8. Negative 1 goes this way. So about right here. H, A plus K. Pick a point. I'm probably picking 0. So I get 1/8. 4 to the 0 plus 1, so I get 1/8 times 4, which is 1/2. So I'm going up a half. So if I connect these, does this look like a growth graph to you? Yes. What's the domain? It's always negative infinity to infinity for exponentials. How about range? There you go. How about in behavior? As x approaches infinity, f of x goes to infinity. As x approaches negative infinity, that's right, which is your asymptote. What am I missing? Y-intercept, I already found the y-intercept. I found that whenever I plugged in 0 for x, so the y-intercept is 1/2, and my asymptote, of course, we said is 0. Say that again? As long as it's a growth graph, yes. If it's a decay graph, it'll be as it approaches. DJ, Logan, Halo, Alan. Yep. All right. You're not on that list, so. Begin to turning. Which other one did y'all say? 11? Yes. Growth or decay? Growth. Above or below? Right, that's correct. It's below the asymptote, but the asymptote is up to 5. Give me a point on the graph. 0, and then h, a plus k. So 5 plus negative a third. Oh. What did I do? Did I just mess up everybody's notes? You're following? I'm sorry. I don't even know what's going on with this board. All right, so negative a third and 5 would be 4 2/3. 4.67, somewhere in there. 1, 2, 3, 4. This is nice because there's my y-intercept also. You can go ahead and fill in that blank. Pick a point. Any point. I'm probably going with 1 because I always just add 1 to that starting point. Yeah. Four and 2/3. 4.67, yeah. Negative 2 plus 5, which is 3. So I get 1, 3. Let's connect these and make sure that this looks like a reflected growth. It does. If I flip that over the asymptote, it would still look like a growth. What's my domain here? How about the range? There you go. It's flipped. 5. What else do I need? I got the y-intercept. In behavior, as x approaches infinity, f of x goes to negative infinity. How about as x approaches negative infinity? Asymptote, of course, is 5. And then you said Zahar, you said 7. Growth or decay? Decay because B is less than 1. Where's my asymptote? -3. Am I above or below? Above because A is positive. Give me a point on my graph. -4, -2, HA plus K. 1, 2, 3, 4, 1, 2. Pick a point. I'm going -3 because I always add 1. 1/2 to the first -3, which would be -2.5. Yeah. H, A plus K. So I'm hugging this way and I'm coming up this way. I might say something different. I don't know. I might decide to leave something. I don't know. So if somebody's not in class, then they literally have everything that we did in class. Right. Right. What? 1. If you pick -5, it should still work. You just get a crazy decimal, I think. Yeah. If I need to find the y-intercept here, that's probably going to be a little bit harder because if I plug in 0 for x, I get 1/2 to the 4th minus 3, which is 2, 4, 8, 16. 1/16 minus 3. Oh. -2.9375. Well, my pen's not right. Bless you. Domain. Range. There you go. Yep. Every single time. So yesterday we graphed. Today we're solving. We're going back algebraic. All right, this can get sticky, so stay with me. I'm going to try to explain it in the simplest terms that I know. Tell me this. If I have, tell me what you know x has to be. 5, right? It's not a trick question. If those bases are the same, then their exponents must also be the same, right? What if I changed it to it's still, because these bases are the same, then x must be, go look there. I gotta, any questions about that? That's a pretty easy concept, right? It's an easy concept, but yet it'll throw you off sometimes. So takeaway here. if the bases are the same, so you have some exponential equals some exponential, then the exponents must be the same. Exponential. Exponential. Now, it may be that you have to combine some first. It may be that you can solve it exactly the way it sits, or it may be that you have to do what I call base manipulation sometimes, and I'm going to show you each one of those scenarios. Y'all got to solve for x. Tell me what you're going to do first. The bases are the same. I just have one exponential piece equals one exponential piece with the same basis. So if the bases are the same, then it follows that the exponents are the same as well, right? So if this is true, then 4x plus 5 must equal x minus 7. How do you solve that for x? Minus 5. 4x equals x minus 12. What do you do now? Close. Do something else first. You got to move that other x over here, right? So I got to subtract x. So I get 3x equals negative 12. So what does x equal? Negative 4. Pretty easy. If only it would stay that easy. Yeah. Would your answer what? Yes, it just stays x equals. Yeah. So at the end of the day, that's what you're trying to find is the variable. Well, let's kick it up a notch because that's what we do. What if you have a scenario they're all exponentials, they all have the same base, but there's more than one thing going on one side? Any ideas what I can do in order to solve this? How do you multiply that? This is supposed to be in K, by the way. How do you multiply? What's this? What are the... You add the exponents. Remember that property of exponents we have that says if the base is the same, then I add the exponents, right? That's what I'm going to do here. So this is going to become 3, and then I'm going to add these exponents. K plus K is 2K plus 2. So I'm constantly trying to get back to, ooh, scared me. So 2K plus 2 equals 5K minus 1. Get the K's together and the numbers together. I'm probably subtracting 2K. Add 1 and divide by 3. So yes, K equals. Still fairly easy, right? What if I made it just a little bit harder? Let me give you one to try, and then we're going to talk about a base manipulation type. Y'all are really quiet today. I'm not complaining. He just called Coach Collins or something. Yeah. No, but it was 14. We only heard one at the end of the argument. What if he did? Well, it's all recorded. Second, to get just one exponential piece. So I got 10 to the fifth, and then I got 10. If I add this and this, I get 3v minus 7. Yeah. Now that the bases are the same, I can drop those off and set the exponents equal. Now I'm going to add the 7 to both sides. Hey, who said they got 4? Zahar, is that you? That's right. No, you don't. So add 7 and divide by 3. Y'all ready to make it harder? Not too many more. The last part is what I call base manipulation. So what's going to happen here is all of a sudden my bases are not the same, and I have to force them to be the same. So that's what I mean by this. Force the same base. How in the world am I going to do that? So what I'm going to do is I'm going to look at the numbers that are there, and I'm going to rewrite them so that they have the same base. And let me show you exactly what I'm talking about. Let's say I have 6, we'll start easy. 6 to the 2x minus 10 equals 36. Okay. Clearly the bases are not the same, right? I've got a base of 6 and a base of 36. But is there some way that I can write both of these to have the same base? 6 to the second power is the same thing as 36, right? Key here is the base still has to keep its same value. You can't change it from 36, but you could write it another way. Kind of like for 5, I could write that as 2 plus 3, right? But it still has the same value. I can write it a different way, but it's got to have the same value. What'd you find out? Do we all agree that it's the same? Now we've got the same, right? Nothing's changed. I haven't changed the value of anything. 6 to the second power is still 36. So now what I'm going to do is I'm back in the same situation where I can just drop off the bases and set the exponents equal. I told you I'd start easy. Don't get excited just yet. We'll do another easy one. No? Jump into a harder one?
Yeah.
Okay, this is not as hard as it gets, but don't blurt it out when you figure it out. This is actually really easy once you know what to do. What? Charlie, what'd you get? -1 for what? The answer? How? Okay, so what happens? Y'all are thinking. I feel like you're getting there, but you're just not there. You got to make them have the same base, right? What's the base? Okay, so we're flipping something, right? What makes something flip? A negative. So this is already 7. So if I make this one 7 to the what? -1. Negative what? Yes, the answer is -3. Okay. This isn't the hardest one yet, but it's getting there. No, not whenever you're rewriting, because you're not really doing anything to it. You're just writing it a different way. -3. This one's a little bit harder, which is what? You can only solve these when you have the same base on both sides. What is your base going to be? Why not make it 3? I agree. I don't know what they're talking about. 3 to the what power is 27? Third. But look, here's where this one gets harder. There's already an exponent here, right? So this is going to be 3 to the third, and then 2x plus 6 equals 3 to the 2x. Here's what makes this one hard. When you drop off the bases and set the exponents, it's all of this. So it's 3 2x plus 6 equals 2x. I can't just solve this the way it sits because I'm going to have to do some distributing first. Okay, so if there's already an exponent that sits out there and you change it a little bit, the exponent's going to have to multiply to everything outside. So this is going to be 6x plus 18 equals 2x. Or you could say -9 over 2. Not terrible. One more. If you can get this one, I'll stop. Y'all ready? It's a good habit, but no. Mark said no. Q's.
I got it 4.
4. 16 would be 4 to the what? -2. Now I can combine these two. And now I can set the exponents equal to each other. Yep. I'm going to move the 2x first. So -2 equals 4x plus 18. Now I'll move the 18. I got -20. So what is x?